day 13 of 75 in our DSA and Java challenge. And today we're cracking open the data structure you reach for 100 times a day and probably can't fully explain, HashMap. Here's the uncomfortable truth. Most developers misconfigure it, break the equals/hashcode contract, and then freeze when an interviewer asks why their O1 lookup is secretly O(n). By the end of 5 minutes, you'll understand the internals, master the modern APIs, and know exactly when to pick HashMap over its cousins. Let's go. First, the internals. A HashMap is an array of buckets. When you put a key, Java calls hashcode, spreads those bits, and maps the result to a bucket index. Multiple keys can land in the same bucket. That's a collision, stored as a linked list. The default load factor is 0.75, meaning once the map is 75% full, it doubles capacity and rehashes everything. And here's a detail interviewers love. Once a single bucket holds 8 collisions, Java treeifies it, converts that list into a red-black tree, turning worst-case lookup from O(n) into O(log_n). That's why HashMap is O1, average, but only average. Now the bug that haunts everyone. If your key is a custom object, you must override both equals and hashcode. Picture a point class with x and y. You insert point of 1, 2, then look up a brand new point of 1, 2, and you get null. Why? Without hashcode, Java uses object identity, so two logically equal points hash to different buckets. The contract is strict. If two objects are equal, they must return the same hashcode. Override one without the other, and you get silent, maddening lookup failures. The fix in modern Java? Make pointer record. Records auto-generate equals, hashcode, and to string from your components. Correct? Every time, zero boilerplate. Let's talk patterns, starting with frequency counting. The old way. Check if the key exists, get the count, add 1, put it back. 4 lines, easy to fumble. The modern way is 1 line. Map.merge, C, 1, integer, sum. For each character, merge inserts 1 if absent, otherwise applies sum to combine the old and new values. Counting characters in a string becomes a clean 2-line loop. No null checks, no get or default gymnastics. This single method shows up constantly in anagram, frequency, and sliding window problems. Burn it into memory. Next pattern, grouping with compute if absent. Classic problem, group anagrams. For each word, sort its characters to build a key, then collect words sharing that key. The pre-Java 8 version needs contains key, a new array list, put, then add, verbose and error-prone. With compute if absent, it's 1 line. Map.compute if absent, key, k, new array list, .add, word. It creates the list only if the key is missing, then hands it back so you can append. One trap, don't use a char array as the key. Arrays compare by identity, not contents, so every key looks unique. Wrap it with string.valueof on the sorted chars instead. Now, which map do you actually pick? 3 choices. HashMap, no ordering. O1, average operations, your default. Linked HashMap, preserves insertion order, or with the access order flag becomes a ready-made LRU cache. New linked HashMap with capacity 0.75f, true, plus a remove eldest entry override, and you've got a 3-line LRU. Tree map keeps keys sorted, backed by a red-black tree, so operations are O(log_n), but you get range queries and floor key and ceiling key for free. The decision rule, need ordering by insertion? Linked HashMap, need sorted keys, arrange lookups. Tree map, need raw speed and don't care about order? HashMap, 2 interview questions test exactly this. 2 sum, 1 pass, store each number's complement in a HashMap, check before inserting O(n) instead of O in superscript 2. And top K frequent elements. Build a frequency map with merge, then bucket or heap by count. Both live or die on understanding that HashMap gives you O(1) average lookups. The entire reason these problems collapse from quadratic to linear. Day 13 done. Remember, equals and hashcode travel together, merge and Compute if absent, kill your boilerplate, and pick your map by the ordering you need. Subscribe for day 14, where we tackle sets and deduct patterns.